Hi, I'm Sai, and this is Project Vayu by both me and my partner Samet. Our mission statement is very simple. Our mission is to design and build a fully autonomous, self-powered wind turbine that leverages real-time meteorological data and automated orientation tracking to maximize the clean energy capture efficiently, sustainably, and independently. Our solution in one line is an autonomous self-powered wind turbine that uses live weather data from websites such as NOAA to automatically rotate and optimize energy capture every 10 minutes.
Currently in society, we have two main types of cars that are used, which are gasoline-based cars and electric vehicles, or EVs. So gasoline cars, they produce a very negative environmental impact because they produce vehicle emissions, which directly causes air pollution. And also they use fossil fuels, which causes climate change, making the environment hotter. And one might think that a valid solution to this is electric vehicles. But these EVs, they rely on grid electricity, which also uses some uses of coal and fossil fuels. So it therefore also negatively affects the environment to some extent. And another issue with both of these types of cars is that these stations, these gas and charging stations, they're not always readily available for people in some areas. That's where our solution comes.
Project Vayu has four main components. One, it captures kinetic wind energy to charge an onboard battery. This is similar to most wind turbines, but where Project Vayu stands out is its flat-back design for its blades. This allows it to capture more wind energy because of its curved nature. Secondly, it uses a microcontroller to fetch live accurate meteorological data from websites such as NOAA every 10 minutes. This allows the wind turbine to then change its direction to increase and get more wind energy. Finally, it uses the data and an internal motor and turns the top of the turbine toward the direction of the wind instead of the whole turbine because the top of the turbine would require much less energy to turn. The green aspect of this project is using wind power and making sure that this process is much more efficient than current technologies.
So here we have a list of materials and their costs for Vayu, or specialized windmill. So one important thing is that a lot of our products are coming from reputable sources such as Amazon, Adafruit, the Battery Store, Robot Shop, Arduino Store, and more. And this just shows how reputable our product will be when it comes to the sources. And another thing is that we would be sourcing the windmill, the actual windmill, from our engineering class, which the teacher, Mr. Krantz, will be providing our model windmill, and we would 3D print the blades and we would attach it on there. So that's not accounted for the cost. The total cost comes out to $75.25, and with the iterations, we hope to maximize the $250 budget and make sure that we get the best product available.
Our in-school mentors are Mr. Jeffrey Bauer, EHS Engineering Graphics teacher, and Ms. Kriti Singh, EHS Physics teacher. Our out-of-school mentors is Dr. Stephen Berg from the Rutgers School of Engineering, who is an assistant professor, and Dr. Yossi Cohen, who is also in the Rutgers School of Engineering and is an assistant professor too.
Here we have our timeline for the project. So in the summer, we would be buying all materials and we would learn how to assemble the windmill. And then in September to November, in the fall, we would 3D print the blades for the windmill and we would assemble the windmill. And then from December to January, we would make the software using the wind patterns and connect the software to the rotation motor. And then from February onto the Capstone day, we would test the windmill many times outside and record it, and we would collect the data and finalize the presentation.
I chose this product because I'm very passionate about green engineering and how it has the potential to power our entire world. Specifically, I'm interested in electrical and mechanical engineering and the creation of this turbine and the use of motors to power both the turbine and our grid beautifully connects both electrical and mechanical engineering.
So I'm interested to do this project because it creates a very sustainable solution to making windmills more efficient. And also I have a lot of interest in 3D printing, which would be useful when it comes to 3D printing the blades for the windmill. And I am interested in mechanical engineering, which is very integral for this type of project.